This tutorial will take us through the steps for performing cell segmentation. In this tutorial we want to turn this fluorescence image on the left into this segmented image on the right, where each individual cell has been individually segmented. To do this, we want to duplicate the cell image, because we're going to perform two different steps on this image. In the first step, we're going to identify each cell using a find maxima function. Here we can preview the number of points, enter the correct value, which for this data is 400. We want to segment the particles, which uses a watershed function to separate out the cells, and we want to exclude any cells which touch the edge. Click OK, and this gives us our segmented cells. We can save this as mask 1. The duplicated image, we're going to define the area of all the cells. To do this, we're going to assign a threshold, and we can manually change the thresholds to identify the area occupied by the cells. In this example, the value is 388 using the default algorithm, and before we click apply, we want to clean this data up by going to process smooth and then clicking apply. This creates a binary image defining the area of the cells. And this is saved as mask 2. The next step is to combine mask 1, which separates each of the cells, with mask 2, which defines the area of the cells. We do this under Process Image Calculator. Let's take mask 1 and mask 2. This starts to segment out the individual cells within the image. Now we need to clean this up a little bit. We still have some small fragments sitting within the image, like here. This can be cleaned up using the Analyze Particles function and setting a filter of anything above 250 pixels squared. And we want to again exclude on edges, and we're going to create a mask. We'll click OK, and this plots only those structures which are over 250 pixels squared. We need to invert the lookup table. And one final step is to clean up the structures, binary, process binary, fill holes. This we can then save as mask 3. In order to analyze this data, we can go back to Analyze Set Measurements to define the parameters we want to read out. In this case, area, shape descriptors, integrated density, mean gray value, perimeter, ferrous diameter. And we want to redirect back to the original data. So we're going to use the new mask that we've created to quantify what's in the original data. You could also redirect back to another channel. Click OK. And then we go back to Analyze Particles. We want to show outlines. We'll keep the same filters we had previously. This time we want to display results, clear previous results, and summarize the data. This gives us outlines, annotated outlines of the cells. The summary gives us a count of the number of cells in the image. And the data is for each single cell with each of the parameters defined in set measurement.